Some of the most successful people in the world are the ones who've had the most failures. J.K. Rowling, who wrote Harry Potter, her first Harry Potter book was rejected 12 times before it was finally published. Michael Jordan was cut from his high school basketball team. He lost hundreds of games and missed thousands of shots during his career. But he once said, "I have failed over and over and over again in my life, and that's why I succeed." These people succeeded because they understood that you can't let your failures define you. You have to let your failures teach you. You have to let them show you what to do differently the next time. So if you get into trouble, that doesn't mean you're a troublemaker. It means you need to try harder to act right. If you get a bad grade, that doesn't mean you're stupid. It just means you need to spend more time studying. No one's born being good at all things. You become good at things through hard work.
Hi there, and welcome to your second Milestone project. This project is going to be pretty cool, and it's going to allow us to store the books we're reading and then go back and mark them as read, so that, for example, we can keep track of everything we've read so far and what we want to read in the future. The most exciting part about this project, though, is the way we're going to build it. We're going to start by using an in-memory database, which is just a Python list. Then we're going to extend it so that instead of saving things in a list, it saves them in a file. And afterwards, we're going to extend it further still by saving things to a SQL database. Building the project in these three distinct steps is going to help us really understand what's going on behind the scenes. So please bear with me as we go through this. We're going to have some coding sessions like the one you see in your video right now, interspersed with some slightly more theoretical sessions where we'll talk about databases and how they work, and also how to use them. If you don't know what a database is, don't worry. Through this section, you're going to understand exactly what goes on inside a database and why we want to use them. The Milestone project, though, is going to be a book list. So in the next lecture, you're going to have a brief explaining exactly what I want you to do for this project. But I also wanted to give you some brief instructions in this video just to help you along your way. Our project is going to have two files. It's going to have an app file, and it's also going to have a package which is going to be called utils, not ITOs, utils. And inside utils, we're going to have another file which we're going to call database.py. This database.py is going to be concerned with storing and retrieving books from a list. Okay, so it's not really going to be a SQL database just now, it's going to be an in-memory database. And we're going to have a books list, which is going to be an empty list to begin with. And we're also going to have some functions here to add a new book to our list, to retrieve the books from our list, and so forth. The brief is going to have a lot more information on exactly the layout of this file and how it's going to be used. In app.py, we're going to have our user menu. Of course, this is going to be a text-based application. We haven't looked at making graphical interfaces just yet. So we're going to do everything via text. For that, we are going to have two things. First one is we are going to import database in order that we can deal with saving things to our books list and so forth. And we're also going to have a user choice. And this is going to be a multi-line string, which is going to describe to the user what they can do. So I'm going to just copy it from my notes here, like so, your choice here. So the user choice is what we're going to print out for the user to know what sort of things they can type. And that's going to be A, to add a new book, L, to list all books, R, to mark a book as read, D, to delete a book, and Q, to quit. We've already created a menu for our last Milestone project, so you know how this goes. We're going to have a menu here, and then we are going to sort of get the user input. And then we're going to have a user input is not Q while loop, and here we're going to ask the user stuff. Sorry, not going to ask the user stuff, but we're going to actually deal with the user's input. So if they enter A, we're going to call a function that adds a book. If they enter L, We're going to call a function that lists all books and so forth. So down here, you'll probably have something that looks like prompt add book and def list books and def prompt read book and def prompt delete book. Like so. So each of these functions should do something. This one's probably going to ask for book name and author. This one's going to show all the books in our list. This one's probably ask for book name and change it to red in our list. And this one's going to remove book from list. Ask for book name and remove book from list. So these are probably going to be your functions. In the prompt add book, you're going to be interacting with the database file to add a new book to our database. What I'm thinking is the database file will have something like add book, and that's going to take the book name and author, and it's probably going to do something like books, append, name is name, and author is author, and red is false, because it's not been read at the start. Okay. Now you'll have to create other functions here to do things like retrieve all the books from our list. You're going to have to add something to modify a book so it is now red. And of course, delete a book. And also you'll have to implement this menu here and all these functions. Read the brief in the very next lecture. It's got a bunch more information on exactly the motivation behind this project and also some hints and tips to help you along your way. But please do attempt this on your own before moving on to the next programming video where we will be implementing this. I'll see you soon.
When I stopped thinking about myself and I started thinking about how can I be useful to other people. And I think that I did not grow up and become the person I am until I was less focused on me and I was more focused on how could I be useful? Who could I help? Because the amazing thing is when you help somebody, when you're a positive influence on somebody, when you're working hard on behalf of somebody, and you see that impact, that gives you confidence.
Hi and welcome back. In this video, we're going to be implementing our Milestone Project 2 using our in-memory database, which is a Python list. I really hope you did give it a go following the project brief and you tried to implement this project on your own, and hopefully you succeeded and made it work. You can always ask questions in the course Q&A if you need help with anything specific before moving on. But now that you're here, let's go and implement this project using lists as our in-memory database. Of course, the first thing we'll do is define the user interface so that the user can interact with our program, and then we can add functionality little by little. The first thing we've got is we ask the user to enter their choice. That's A, L, R, D, or Q. If they enter Q, we're not going to go into this loop. So in here, we have to deal with 4 options. If the user input is A, if the user input is L, if the user input is R, and if the user input is D. And if it's none of them, we can print unknown command, please try again. Okay. Now, of course, in order to go back to the top of the loop with a different user input, we must reset the user input to something else. For that, we're going to ask the user again, but make sure that that's not inside the else or anywhere. Just here within the loop outside of any of these statements. I also gave you a few hints of what you could call your functions. So I'm just going to use those names here. So I'm going to call prompt add book, the function that doesn't exist yet, when they type A. We're going to call list books when they type L, prompt read book when they type R, and prompt delete book when they type D. The reason why these functions have prompt in front of them is because these functions aren't just going to do things, they're also going to ask the user for something, and that's just my way of telling myself, these functions are going to ask the user, and they have to ask the user for some information in order to do what they want to do. If you want to add a book, you have to ask the user for the name and author. If you want to read a book, you have to ask the user at least for the name. And if you want to delete a book, you also have to ask at least for the name. Okay, so let's go ahead and implement our functions. Python styling suggests we leave 2 blank lines between 2 functions, so we're going to do just that. And then we're going to define our prompt add book function. What this is going to do is ask the user for name and author. So name. And the author. And then all it's got to do is ask the database to save this book. Notice how it's not going to interact with the books list directly, but it's going to ask the database to save the book to the list. So what to do here is say database.addBook, name and author. Now when we call this, we pass the value of name, a string, and the value of author, another string, to our addBook function. And this is now going to use this global variable to append this dictionary, which represents our book. It has a name, an author, and a read status, which starts off as false. We're going to be able to change this later on. Okay. Now we can delete our first comment, for we've already accomplished it. Once again, leaving 2 lines, we can say list books. And the list books is just going to ask the database for all the books. And it's going to print them off one by one. So for book in books, we're going to print some representation of the book. We can do that later. For right now, we're just going to print the dictionary that will come back. Remember, we're storing dictionaries. Dictionaries are going to come back. The getAllBooks function does not exist, so we're going to create it in the database. And what should this function do? Well, in order to get all the books, all it has to do is return this list here that will contain all our books. So just return books will do. When we step up this program and work with files, this is going to get more complicated, of course. It's going to have to actually open a file and read the contents. And certainly when we move on to databases, it's going to get even more complicated, as we will have to connect to the database and retrieve the data. But for now, because we're using a simple in-memory database, we can just return the books there. Now we can delete our list books comment there, since we've already implemented it. Let's move on to prompt read book. And this has to ask for the book name and then go to the database and change it to read. So, name. Enter the name of the book you just finished reading. And then all we want to do is say database mark book as read with that name. Of course, this function does not exist, so we have to go over to our database.py and define that. Mark book as read. And it is given a name. This parameter here will receive the string that the user entered, and that should be the name of the book. So how would we mark a book as read, knowing that we have a list of books? If you didn't try this before, then I hope you paused the video there for a moment and gave it a go. All to do is just iterate over the books, and if the book was read, if book is equal to the name that we gave it, then say book read is now true. Okay, that's it. Just go over the books, and for each book, modify it if the name matches. Of course, this does suggest that if 2 books have the same name, they're both going to be changed over to be read. But, we can deal with that problem later on. If you want, of course, you can change this to take 2 arguments, the name and the author, and that gives you a bit more granularity in what you do. Finally, we're going to delete this comment here and define the prompt delete book. Once again, this is going to take a name, and it's going to do database.deleteBook with that name. Naturally, that also doesn't exist, so once again we go to our database and we define that function. So how may we do that? This is the slightly more interesting thing. There are a few ways in which we could delete a book. Pause the video and give it a go if you haven't already. One way that my students frequently come up with removing a book is by going over to the list documentation and see whether lists have any way of removing elements from them. And normally we end up with this. Go through each book. If the name matches what we want to delete, then do books.remove book. Because the list objects have this .remove method in them, and they take one of the objects in the list and allows you to remove the object entirely from the list. So this would certainly work. However, it is generally considered bad practice to modify a list while you iterate over it. That's because as you go from one element to the next, elements are disappearing, Python can get a bit confused, so generally not a good idea to remove elements from a list while you iterate over it. However, this is a way that you could do it and it would work in the majority of circumstances. Instead, I would do this. The first thing we want to do is say books is equal to, remember that's our variable up there, and now we're going to use a list comprehension with a conditional. A list comprehension with a conditional is going to go adding each book over to this new list if the book's name is not equal to the name we got as an argument. Add each book to new list if book name is not equal to the name argument that we got here, the name parameter, sorry. Once again, I'd encourage you to pause the video and give this list comprehension a go, just for practice. Make sure that you've not forgotten how to implement list comprehensions. And if you have, then continue watching and we shall implement it. Okay, I hope you got that, but if you didn't, that's totally fine. All we want to do is create a variable for book in books, and then we only want to put it inside the list. Remember, this is the value we're putting in our new list if the book name is not equal to the name argument. I'm going to delete this comment now from there since we don't need it any longer. So this is going to put the book element into a new list for book in books, which is our list, if the book's name is not equal to the parameter. But of course, Python doesn't quite like this. And there's a really good reason why I'm getting a red line, and this is something that you should preempt against and you should understand. The reason why it's giving me a red line is because of the concept of scope. Once again, I did mention that scope would appear throughout the course a number of times, and this is an important scenario for understanding scope. What we've got now is we have a global variable called books. However, Python has also created a local variable to this function. This variable books only exists within this function here, and it is not the same variable as the global variable books. So now it thinks that we are setting this variable, we're creating this new variable books, but we are also using it in the statement that creates it. And this is obviously nonsensical because this variable doesn't exist yet since it's being created in that same line. What we have to do is tell Python that we don't want to create a new variable. We want to use the global variable books. Another option would be to rename this variable. Books new is that, and then it doesn't complain anymore because it realizes that this variable we're using must already exist. So instead of looking in the local scope, it looks in the global scope. However, we don't want to do that because we want to change this variable. And in order to do so, we must tell Python that we are looking to use a global variable, and that's really straightforward. We just do global books. What this does, essentially, is say books in the local scope is equal to books in the outer scope. Makes them the same, and then we can use it as normal. Now it knows that when we use this variable, we refer to the outer variable, and similarly here, we're also referring to the outer variable. So we're not looking to create a variable in the local scope. Okay. That's it for deleting books, so we can go back to our app.py and delete our last comment. And now we have our application completed. Of course, I went through this quite quickly. I'd expect you to take substantially longer the first time that you develop this, as per the brief. But if you've gotten this far with me, now you hopefully understand what's involved in making this app. We just have to get the data from the user, create dictionaries for the books, and then store them in a list. Each of the other operations is just going to go through our books and change them, go through our books and delete them, or just let the user read them. Now I'm just going to make a small improvement in the list books function. I'm going to print something a bit nicer. So I'm going to print the book's name. Oh, of course, when you use the single quotes inside a dictionary and you've got single quotes outside in your F string, it doesn't like that. So I'm going to use double quotes on the outside, and just for Python's benefit. I'm going to say book name by book author, and read is going to be book read. So this is going to be something like fluent Python by the author, read, false, or true. In my case, it's false. I haven't read it yet. Okay, the author is, by the way, is Luciano Ramalho. I think that's how you say his name. It's a good book. You should read it. So now we've got the name and the author, and read is either true or false. If we want to make that a bit nicer, we can say something like read is yes if book read, else no. This is a ternary statement in Python. It just means use this value if this is true, otherwise use this value here for assigning to the variable. So if book read is true, it's going to say yes. If book read is false, it's going to say no. And remember, this is essentially the same as this. Book read is true. You can remove the is true as we looked at in the very first section of this course. Now instead of book read, we can just use read, since that's the variable we've created here. Okay, let's go and run our app and see what happens. Nothing. Of course, we've not ran the menu function. So let's go over down to the very bottom and run the menu function. And now we see our input. I'm just going to extend this a little bit. We can add a new book. Let's say, for example, Clean Code. This is a good book as well. You can also read it. It's by Robert C. Martin. And that's it. We've added it. Now we can press L to see them. And we get Clean Code by Robert C. Martin, read no. We can add another one. Let's say, for example, Test-Driven Development by Kent Beck. Also a good book. Now we can list them, and we can see that we've not read either Clean Code or Test-Driven Development, but we want to. So let's go ahead and read Clean Code first. So we type R, and by the way, add a space after your choice. This is poor planning on my part. It just looks awful. Enter the name of the book you just finished reading. Let's say Clean Code. Now we can list the books again, and we see that Clean Code says yes. Of course, when we quit and we start again, we don't have any books because we've stored them in an in-memory database. That is a database that lives in memory, in the memory of our computer, which is volatile and is only available for as long as the app is running. As soon as we stop running, that database gets erased by Python to save memory. We don't want this, so what we want to do is go ahead and use a file instead. And now you understand why I have tried to decouple our database from our app. Now, nearly all the changes are going to be in the database file for us to swap over to files instead of in-memory database. Here's an example. Books is now not going to be a list any longer. It's going to be a file name. For example, books.txt. Add book is going to open the file and it's going to append a book to it. Get all books is going to read the file and return all the books in it. Mark books as read is going to read all the books. It's going to change one and it's going to rewrite them to the file. And delete book is going to read all the books, it's going to delete one, and then it's going to rewrite it to the file. You can store the books in CSV format or in JSON format. It's up to you. Of course, if you store them in JSON, it's slightly easier to work with since we've already worked with dictionaries here. But if you store them in CSV, it's not much more difficult either. In the next video, we're going to go over changing this to use CSVs. So I'll see you there.
This perfect person, this right person, this correct person, nobody is right, nobody is correct. Trust me, the biggest stars that you all love, nobody is absolutely right. And everyone's making mistakes and it's completely normal. So accept that and accept that so that we're all actually the same. Just doing different things, exactly the bloody same.
Hi and welcome back. In this video, we'll be turning our project, which used an in-memory database, into one using files for storage. What we've got here is our database, which is a list. So the first thing to do is to start transitioning our database.py file from using this list to store things into using a file. This is the reason why I've structured the code the way that I've structured it for you. Now, if we want to add a book, we already know how to add a new line to a database, or if we don't, we're going to learn in this video. We already know how to read a file and get all its contents. We already know how to save into a file. We already know how to read a file and delete something and then save it again. So this database.py here is what's called an interface in programming. An interface between our business logic, what a program is supposed to do, and the storage, which in this case will be a database, a file. And we're going to move on to database soon. So if we wanted to add a book, that would be very straightforward. All we have to do is, well, first of all, before we actually start writing any code, is change this to a CSV file and decide on the format of the CSV file, which I think should be name, author, read, like so. Now that that's clear, we have decided that we're going to store name, then author, then read, separated by commas, we can continue. Notice that it could be beneficial to separate it by hashes instead, because the titles may have commas in them, but for now we're not going to worry about that. You can make that change later on if you want. So to add a book, all we have to do is say with open books.txt in read mode as file, and here, write mode as file, and here what we're going to do is add a new book at the end. I'm just going to delete this thing here. However, I mentioned earlier on when we started looking at files that write mode would erase all contents of the file, and then you would be able to start writing from the very top of the file. We don't want to do this because our add book should add a new book probably at the end of the file. We do want to keep the other books that are already in the file, otherwise we'll only ever be able to have one book at a time. Instead of W mode, we can use A mode, which stands for append. So anything we write will automatically go to the very end of the file. Because our file is going to have this structure, and then it's going to have a \n at the end, anything we write is always going to be at the very bottom of the file. Here's why. We're going to add a book, and that's going to be in this format: name, author, read, new line. Then we'll add another one, and because there's a new line, it will go on the next line. Then when we add another one, it'll go on the next line, and so forth. So it's important that we include that new line there, because append mode will just go to the very end of the file, the very last character, which will be the new line. So all we have to do is file.write, name, author, and then we have to decide on how we're going to store false values. Because the text file that we're going to be using is not a Python file, maybe false doesn't make much sense. Although it could, it's up to you. But I'm going to store it as 0. 0 for false, 1 for true. It's up to you what you do. And this is how we would add a new book to books.txt. Notice though, we still got our books variable up here. We don't need that, so I'm going to rename it into books file, and this is going to be books.txt, and this is going to be books file. That way, we're storing the file name up here. That's essentially our database. To get all books is going to be slightly more challenging. Once again, I'm going to go here and have a couple of lines of name, author, read, just so it's a bit clearer what we're doing. And the first thing we want to do is, of course, open the file. You know how to do this. With open books file in read mode as file. And now we want to get all the lines. But we want to get the lines without the white space. I hope you remember how to do this exactly using the strip method. We're going to say lines is line.strip for line in file.readLines. That's going to read all the lines, including the \ns, and it's going to give us each one in a list, in an element of the list, and for each of the elements, we're going to strip the white space, which is going to remove this here. So now we're going to have this as our contents of this list here. Now, we can also chain to it a split so that we will get one list of lists. Indeed, now our list will have this format. Like so. So we'll have one list, and inside it we'll have sublists, where each one is going to be a list of name, author, read. Now what we're going to do is we're going to construct our book dictionaries. So this is going to be another list comprehension. In the list, and notice by the way you can put list comprehensions in multiple lines, it's totally cool, totally fine. Line 0, author is going to be line 1, and read is going to be line 2. Of course, line doesn't exist, so we're going to do for line in lines. And there we have it. Remember that each line, or rather the whole lines list has this format, name, author, read. Name, author, read. So for line in lines is giving us one of these lists. And then we're saying that name is the 0th element of this sublist, which is the name. Author is the first element of this sublist, which is the author. And read is the 3rd element of this sublist, which is the read status there. Then we can return books. Or indeed, if you want to save some space, because this variable here is pretty redundant, we can just say return this list comprehension. That's going to execute the list comprehension first and then return it. Okay, we've got the get all books and the add book. Now we can move on to marking a book as read. This is not so easy because although it's possible to go into the file and modify it, it's actually much easier to read the file in, modify the book that we want, and then save them all to the file again. That's actually much easier. So we're going to go for that in this video. The first thing to do is, of course, to say books is get all books. Okay. For some reason, it keeps saying, oh yeah, this thing here. It kept saying this shadow's an outer variable, but I was pretty sure we deleted it. So I was wondering what the hell that was. But of course, the global books there was creating it again. So we don't want to do that. Anyway, marking book as read. The first thing we want to do is get all the books. Then we want to iterate over them. And well, in fact, we already have it here. For book in books, if the book's name is equal to the name that we passed in, we're going to set it to read, except now instead of true, it's going to be 1, because 1 means true and 0 means false in our file. And then at the end, we have to save all of the books that we've retrieved back into the database, and one of them will have changed from 0 to 1. So for that, I'm going to create another function that I'm going to call underscore save all books, and I'm going to pass it the books that we read, the books variable. This function doesn't exist, so we shall create it. The reason why I'm calling it underscore save all books is because in Python, this tells other developers that they should not call this function. You should only call this function from within this file. This is normally known as a private function in most programming languages. Python doesn't have the concept of a private function, so other people from outside the file can still call this function if they want, but the naming convention in Python says that if a function has an underscore in front, you should probably not call it. So that's what we're doing here, just calling it with underscore first, or naming it with an underscore first, so that other people know that this is a function that they probably shouldn't use. They should only use delete book, mark book as read, get all books, and add book. So, in order to save all the books, well, we just have to open the file in write mode this time, and we're going to delete the entire file and rewrite it. And we're going to go through each book and say file write, book name, book author, and book read. And at the end, make sure to put the \n. That's pretty important as well. And actually, I think we forgot to put it up here. So make sure to file write a \n in there as well. That's important. I did say earlier it was really important, then I forgot. There you have it. So now what we're doing in this function is opening the file, deleting all its contents with the write mode, and then just going through all of the books in the list that we got as a parameter, and for each book, writing out its details in CSV format and a null at the end. So it's just going to rewrite our entire file. Not the most efficient thing to be doing, I'll be honest with you, but it's much easier than going and modifying the file. Okay, so now this underscore save all books function does exist, so we're safe to use it there. And again, what we've done in this function is read all the books, gone through them and modified the one we want, and then saved them all back. And that is essentially the same thing we're going to do for deleting a book. So I'd encourage you to, now that I've implemented these two functions, go and implement the delete book function on your own. Once again, read all the books, recreate the list without the book that you want to delete, and then save them all back. Let's try that. I hope you managed. What I would do is once again say books is get all books. Now I'm going to say that books is actually book for book in books if the book's name is not equal to the name we got as a parameter. And finally, save all books. Notice how the function call here, this function is above this function. And I did say previously that you'd want functions to be defined in the order in which they're used. This is fine because this function was actually used above. So I think this is okay. Again, we're using the list comprehension to iterate over our books and then only put the book into a new list if the book's name matches. Doesn't match. So we're putting in all the books except the one that is here. And that's it. We now have our delete book, mark book as read, get all books, and add book functions. They are still the same functions as before. The names are the same. All they're doing now is they are storing things into a file instead of into a list. So if we go over to app.py, we actually don't have to change anything because database.addBook doesn't know whether this is going into a list or a file, and it doesn't care. All it knows is that the book is being added. Here in list books, database.getAllBooks will get the books, and you don't care where it's getting them from. So we have very well decoupled our business logic, our app, from our database. We've not done a perfect job because the book read status is now going to be, yes, if the book is exactly equal to 1, otherwise no. So now instead of being true or false, it's 1 or 0. So that's the only thing there. Okay, other than that, prompt read book is going to get the name and then mark it as read. And you know that in the background, the database is going to the file, opening it, looking through all the books, marking one as read, saving them back, but your app doesn't care. So what we've created here is a nice interface between our app and our data storage mechanism that very nicely hides all the complexity inside this file. And this is, as I said earlier, normally called an interface, and the interface here is to our database. And the contents of the interface are these 4 functions: the add book, get all books, mark book as read, and delete book. And normally we've been talking about user interfaces because users have been interacting with the menu that we've given them. But this database is an API, it's an application programming interface. We've created an interface so that this part of the program, app.py, can interact with another part of the program, the database, via the interface that we've defined: prompt add book, list books, prompt read book, and prompt delete book. So if you think of app.py as a user, these are the options that it can use to interact with the database. And it doesn't care what the implementation is, whether it's a list or whether it's a file. And indeed, as we move forward into databases, as a SQL database, as a relational database, it won't care either about that. Let's run this app and try it out. And by the way, I'm just going to stop that, and this is annoying me a little bit. We are going to add a space there. Okay, let's run it. We're going to add a new book. We're going to enter clean code by Robert. And as you can see, no errors. We're going to list all the books. And we see clean code by Robert. We can mark a book as read, and that'll be clean code. Then we can list them again. And now it appears as read. We can delete a book. And we can list them again, and nothing appears there. And notice how books.txt has not appeared in PyCharm yet. The file does exist. If you go on your Finder or on your Windows Explorer program into the directory in which this project is, you'll see the file is there, but PyCharm doesn't quite update that quickly, so it's not showing it there. Okay, let's exit that program. Notice how now the file does appear, and let's delete the file. Now let's run the app again. And now I'm going to read books. What do you think is going to happen when I press enter? Well, let's see. Oops, probably not what we wanted. We probably wanted either nothing to print out, or even nicer would be some sort of message saying you don't have any books. But instead we got a file not found error. No such file or directory, books.txt. And the reason for that, I'm just going to hide this away. The reason for that is because when we add a new book, or indeed when we save all books, we are using a constructive method of file opening. So we are creating the file here, or we are creating the file here if it doesn't exist. But the read method is not constructive. It is more passive, and it doesn't create the file if it doesn't exist. Indeed, it gives you an error and it says file not found. So what we want to do is make sure the file exists before we go and read it. And for that, I'm going to create one last function here in our database interface. And that's going to be here, create book table. And I'm consciously calling it table, even though it's a file, because this is called database, not called files. And as we migrate over into a database, this is going to be responsible for creating the table that is going to store the books. If you don't know what I'm talking about, don't worry, we are going to get there very soon. So all to do here is open it in write mode. And you don't have to do anything with it. It's going to close automatically when you exit this context manager. So you don't have to worry about anything. And indeed, as file is optional, so you don't need it either, because you're not going to use the variable for anything. And again, this just to make sure that the file is there. Okay, now we can rerun the app, list our books. Oh, of course, my bad. We created the method here, the function in the interface, but we didn't actually call it. So at the top of the menu, before we ask the user for their input, just type database.createBookTable, and that'll be all you need to do. Now we can list books, and we don't get anything back. Feel free, of course, to continue developing this program, and I just stopped it, and when you stop it, you get a nice error there as well. feel free to add some more stuff to your program. What if there are no books? Print something else out. Add some more data to the books store. You do whatever you want to do. This is your program now. So congratulations on finishing this segment. As we move on, we're going to look at how to store this data as JSON. And if you're interested in that, just look at the next video. If you're not really keen on storing things in databases in files any longer, feel free to skip the next video, move on to the very following one, where we're going to start looking at databases. So I'll see you either in the next video or in the one after that. See you soon.
I got this 10% rule. Whatever I'm purchasing isn't 10% of 100% value of what I have in the bank, I don't touch it. So in other words, let's say hypothetically, if you have a car that you want to buy for $100,000.
Right.
If you ain't got $1 million in the bank,
You shouldn't buy
that car. Don't buy it.
Right.
And that goes with your house, whatever. If you want to buy a house that costs $1 million, if you ain't got $10 million in the bank, bro, don't touch that house because you're not going to be able to afford it.
Hi and welcome back. In this video, we're going to turn our CSVs into JSON, just for us to understand a bit better how that works and whether there's any benefits to using JSON instead of CSV. Often I find that JSON does give you a bit more flexibility and makes things a bit easier, just because it very easily translates into Python dictionaries, and also this just gives you a bit more exposure to how Python works. If you don't want to move this app over to JSON, feel free to just go into the next video and we're going to look at databases instead. First thing to do is to change our comment up here to say we are using JSON. Then I'm going to change the file to be books.json. And now we will begin using our interface here to create our files. Now when we create a book table, we are wanting to make sure the file is there. And we're going to change this later on. We're going to get an error when we try to use this, but let's leave it like that just for now. Then let's first implement the getAllBooks function, because that's the easiest one. So I'm going to delete all of this except the context manager, and all that we have to return is json.load of the file. Of course, we'll have to import JSON at the top. Remember, the JSON file is going to be a list that does stuff and has maybe some books in here. There's like name is name, something like clean code. Author is going to be Robert, and red is going to be true. JSON can store true and false values, so feel free to store them directly in JSON, which simplifies things a little bit. So it's going to be a list of dictionaries, and that's cool. So when we get all the books, we do json.load, and that gives us a list. When we have our list, we can iterate over it, and we can do everything that we could with a normal list. Just pretend that it's this that we've put in a variable. So when we want to add a new book, how are we going to do that? Well, we need somehow to open up the JSON file and write a new dictionary to it. Now it's no longer as simple as appending something at the end, because we have to append something between this curly bracket and this square bracket, something like this. So it's not so easy. So what I'm going to do is do the same thing that we did with marking books as read and deleting them. I'm going to open all the books, read them all, append one using Python, and then save them all back. So books is going to be getAllBooks. Then we're going to do books, which remember is a list, so we can do append to it. And then we're going to append a dictionary using the parameters that we got here. And it's going to start off as false for the red status. Of course, at the end, we want to save all the books. And the books that we want to save are the books that we've modified already. Now, this save all books function is defined down here. So we're going to just cut it and move it down to save all books. But actually, apologies, get all books is used first. So we are going to put it here. Oh, So we will put it there, and instead, of course, of doing all of this iteration, all we have to do in the save all books file function is json.dump books into file. And that's just going to save everything as a JSON string instead of as a CSV. So now we've implemented our add book, get all books, and save all books functions. We can go ahead and mark the book as read. But you may realize that we don't actually have to do anything except turn this one into a true, which is everything that we need to do. Similarly for the delete book, we're getting all the books, now they're coming from the JSON file, saving all the books, they're going to a JSON file, and in the middle we're just modifying the list so that it doesn't include the book that matches the name. Again, we don't have to do anything here. Pretty nice, eh? Not a lot has changed, but the only thing that's changed is the false and 0 and 1. So if we go over to our app.py, we can go down here and just remove this if book read equal 1, change it to if book read, since that already assumes is true. And that's it. We can then press play and, start adding books. And I said that earlier, this is going to raise an error. So I am going to enter a new book name. This is going to be Python 101 by Jose Salvatierra. This doesn't exist, by the way. Oh, we get the error. So this is the error I was talking about earlier, and it says json.decoder.json decode error. Expecting a value in line 1, column 1, character 0. Okay, so it was expecting a value. Let's see what the books.json file says. It's completely empty. Nothing there. Okay, so the error says it was expecting a value, and evidently it didn't find one. So why was it expecting a value? Well, here you can see the line that raised the JSON decode error. It's not something we wrote. It's inside this decoder.py file, and now we're getting lines that we didn't write because, of course, we're using a module that we didn't write, and this is the module that raised the error. That error then appeared in this raw decode function, so that's the next thing we get. That was called from this decode function, which was here, and then here, and eventually we reach our code. Return json.load file. And that was inside the getAllBooks file function. So let's go over there, and let's make this a bit smaller. And it's saying that the error was returned here. Return json.load. Why do you think there may be an error in this line? I'm not sure what you came up with, but the problem here is that our books.json file is empty, and that's not valid JSON. Remember I said that some programs would expect your JSON file to have an object around it? Some will allow a list to be in it, and Python's JSON module is one of these that allow the list, and that's totally valid JSON. There's a few more things that it can be, but it certainly cannot be empty, for that is not valid JSON. So what we have to do is make sure that in the create book table, we are initializing it to some value. So what we're going to do is we're going to say that the initial value has to be an empty list. And then we'll need the variable up here as well, of course. Now, as soon as we create the book table, it's going to initialize the list's value to be the file's value to be an empty list. And then when we go over to add a book and we get all the books, what it's going to do is it's going to read that empty list. And then it's going to append to it. And then it's going to save it back. Now that we'll have some valid JSON in there, let's run this again. And you can see that it works. And this book, by the way, 30 Days of Python, is coming soon. So if you do know somebody that is interested in 30 Days of Python, let me know. So now we've got our two books here. And as you can see, we've not read them. Not read them doesn't exist yet, of course. But then we can mark one as read. And listing them again now shows that one of them is not read and the other one is read. Looking into books.json, we can see that the JSON stored here represents what we're seeing there. Two objects, Python 101 by me, red is false, and another object, 30 days of Python by me, and red is true. Notice how when you call your file .json in PyCharm, it starts giving you some nice syntax highlighting. So that's pretty nice too. And also notice how the false with a capital F went down to a lowercase f, and the true with a capital T went down to a lowercase t. That's because these are the JavaScript equivalents of Python's true and false with capital letters. In JavaScript, they have lowercase letters. JSON means JavaScript object notation, so of course it's going to go down to lowercase as well. That's it. We can delete books. We can delete Python 101 since that one's not happening. List them again. That's now like that. And of course, we can quit and that exits. So that's how you would turn our program from CSVs over to JSON. And all we've had to do is modify a couple of functions to tell our code now to talk to a JSON instead of saving things manually as strings into the file. Pretty straightforward, and our app.py hasn't had to change basically at all, other than this if there. So that's it for this video. Hope you learned something, and I'll see you on the next one.
Do you feel that you're happier right now than when you were broke, or not really?
Sometimes. It's a sometime thing. Like, it makes me happy. It makes me happy that I'm able to afford what I want. And it makes me happy that I get to treat my family. But I feel like the way that I have money kind of took away a lot of my happiness.
Hi and welcome back. In this video, we're going to look at databases. Let's first talk about databases as a general concept, and then over the next few videos, we'll move on to talk more concisely about what SQLite is and what it does, and then we will re-implement our Milestone project using databases. A database is a place where we can store data. Now, we all know this already, but let me give you a bit more information about how databases work. Normally, databases are organized into tables, and each table holds information about one thing in your system, such as cars, or customers, or shops, etc. Something more or less like this could be for your customers. On the left, you've got an ID column, that's an identifier for each customer. Then you've got a name, and then you've got an address. The reason we've got an identifier is because two customers could have the same name or the same address, so neither name or address allows us to identify one customer. They could identify multiple customers. So that's why we have an ID. If each customer had a unique email address, for example, we could use that as the ID instead of a number. But frequently, we use numeric IDs for things in our tables. And normally, it starts at 1 and it goes up 1 per row that you've got. As you can see, this table has 3 columns, ID, name, and address, and 4 rows from 1 to 4. SQLite, which is the database we're going to be using, is a small, fast, and reliable database engine which can run in memory, more or less like our Python list did, without saving any data to the actual physical disk, or it can also run by saving all data to a single data file. That's it, one file on your computer that contains all your data in your database. Now, there is a benefit to having a single data file, which is that it makes everything quite lightweight, quite small, quite easy to move around from one computer to another or from one device to another. And SQLite is frequently used with small devices like your phones, smartphones, iPhones, Android phones. It's also used with embedded applications, and it's also used in reasonably light and simple desktop and web applications as well. You interact with SQLite using SQL, and that means Structured Query Language. And the Structured Query Language is an English-like language that's developed specifically for interacting with relational databases. We're going to look at what a relational database means in a moment. SQL allows for things like selecting data from a database, or inserting it, creating tables, filtering through data, ordering data, and a lot more stuff. By the way, some people say SQL instead of SQL. It's up to you which one you say. Don't hate for me saying SQL. And there are other database systems apart from SQLite, such as the also popular MySQL, and others like PostgreSQL, Oracle, and many more. Okay, so let's look at an example of a relational database. SQLite, Postgres, MySQL are all relational database systems. In a relational database, there is functionality to extract and analyze data in ways tailored for when some data is related to some other data. Here's an example. Here we've got two tables, users and purchases. Now, it may not be directly obvious that these two pieces of data are related, but if you see, the users has an ID column, the purchases has a customer ID column, so the data here is related because by looking at this data together, you can see that two of these purchases were made by the user number 1, and that has a name and an address. So you can relate these pieces of data by using the customer ID column on the purchases table and the ID column on the users table. So that's pretty handy. Most database engines create complex folder structures and save data in various different ways, but SQLite is quite simple in that it creates a single file that contains all your data. SQLite has a limitation, which is that we can only perform one write operation at a time. That means that if you've got two users trying to write some data to the database at the same time, they are not going to be able to do that. Only one person is going to be able to write, and then the other will have to write afterwards. It will have to wait. However, SQLite does allow multiple read operations at the same time. So if you have a lot of users using your program, at the same time interacting with the same SQLite database, they can all read data at the same time. Most database systems, like PostgreSQL or MySQL, allow for many of those at once, either writes or reads. And for example, imagine you were writing a Python app handling hundreds of users at once, performing operations like purchasing items. SQLite would not be suitable because only one user could save their purchase and commit their purchase at a time, so another database type could be better in that scenario. However, if you've got SQLite on your phone, where you're the only user, SQLite could be pretty nice for that. So SQLite is very fast at reading data, not so fast and not so efficient at writing data. Now, when we interact with a SQLite database, you can either open the data file with a text editor. That's just a blank, or not a blank, but a text file that has a bunch of SQLite data in it. But normally I recommend using a proper data browser, like this one, SQLitebrowser.org. As we progress through this section, I am going to be using SQLitebrowser.org to look at the data in our database. Feel free to download it as well, so that you can interact with your SQLite databases a bit more easily. That is the end of this video. We just wanted to look quickly at what a database is, what tables are, what relational tables and relational databases are, and how SQLite compares to some of its competitors. Just remember, it's not so good for many users, it's pretty good for single user, and give you a bit more information on how to look at the data in your database. SQLitebrowser.org is a pretty good and free software you can use to look at that. So that's it for this video. I'll see you on the next one.
I was 26 years old, man. I was struggling. I didn't have nothing. And these people owned the furniture store in Cleveland. They took me in and gave me my first contract with my little carpet cleaning company. When I became a comedian at 27, I didn't have money to travel. They gave me an account at their travel agency. And man, I ran up a bill like $11,000 just trying to travel and make it. Them people right there, man, they helped me out. Hey man, I've been looking for you for years, man.
Hi and welcome back. In this video we're looking at using SQLite from within Python. And it's really straightforward. For Python, comes with SQLite already installed as a package, and all you have to do is import SQLite 3. Open up a Python file, write import SQLite 3 and run that file. If it all works and you don't get any errors, you're good to go. If it fails and you get some sort of module not found error or an import error, it's possible that your Python installation has been made lighter so that it takes up less space in your computer and so forth. And in that case, I have to recommend that you find a way to install SQLite 3 or you reinstall Python 3.6 or later in your computer so that it comes with SQLite 3. This normally will only happen on some very specific operating systems. Now, once you've imported SQLite 3, you can easily connect to a local database. That's how you do it. You do SQLite 3.connect, and then as a string, you give it the data file. Remember, this is going to be a single file that is going to contain all your entire SQLite database. The file is normally named data.db. That's just the convention. You can name it whatever you want, of course. And always, after we finish with a connection, remember to close the connection. Does it remind you of something? I hope it reminds you of files, for it looks pretty similar. Okay, so after you've got the connection, you will want to get a cursor for that connection. That's there in line 3. You get, say, cursor equals connection.cursor, and that gives you a new cursor that you can use to execute SQL queries. I'm going to explain exactly what a cursor is in the next video, so don't worry. Once you've executed your SQL query, you can commit the connection. And what that's going to do is it's going to save the contents of whatever changes you've made into the disk. I'm going to explain that in the next video as well. But this is a pretty normal flow for SQLite queries being executed. You connect, then you create a cursor, you run your query with the cursor, and then you commit the connection and you close it after. So a few questions, of course. What is a cursor? What is commit? And how do we write SQL? We're going to look at these 3 questions in the next video. So I'll see you there.
If you want to become successful in life, young man, he said, number 1, you got to change your mindset. He said, you don't get in life what you want, you get in life what you are. Number 2, practice OQP, only quality people. You earn within $2,000 to $3,000 of your closest friends. I found that out. I left all my broke friends. I said, y'all got to go. Because I used to be so broke, I'd pass a bank and trip the alarm, you know? And the 3rd thing he said, develop your communication skills, because once you open your mouth, you tell the world who you are.
Hi and welcome back. In this video, we're looking at some database jargon that you'll need to know. Starting with, what is a cursor? We're also going to look at what is commit. And finally, just a couple of words on how we're going to write SQL, and then we'll move on to the next video. Cursors. All operations in SQLite are made by cursors and not by the connection object itself. And there's 2 reasons for that. First reason is that if we have a single connection, we can only perform one operation at a time. If we have many cursors, we can use each cursor to read some data and one to write some data. Remember, we are limited to one write operation at a time, but multiple cursors can be reading data at the same time. The cursor also has a specific meaning, and there's a reason why it's called a cursor, and that is when we read some data. Let's say we have this table here, and we tell the cursor to fetch some data, get some data out of the database. The cursor starts there, at the very top, right before our first row. When we tell the cursor to move over to the next line, it will give us the first line, and the cursor will move to the second row. Notice how this cursor is actually like pointing at a place. That's why it's called a cursor, because cursors are used to point at things. And this cursor here is pointing at its current location down the table. When we read the first row, it moves over to the second row. Now, when we ask the cursor to read one row, it's going to read one row after the one it's at now. So it's going to move over to row 3, and it would give us row 2, and so forth. And this is really the main reason why it's called a cursor. Because every time you ask for a new row, it's going to move down, and you cannot go back up. So the cursor just keeps pointing down and moving down as you ask it for rows. Okay, so we are going to encounter some interesting functionality to do with this way of operating soon. Next up, the commit. Commit just means save the result to the disk. And that's because we keep a bunch of data in memory until we commit. So for example, say we want to insert some data into our database. We tell SQLite to insert it. It doesn't actually get inserted. It gets saved in memory until we say commit all of this. That allows us, for example, if we try to insert some data and it turns out to be corrupted or something like that, we can then roll back and not actually save anything to the disk. It also allows us to write multiple things together. For example, we can delete a user and insert a new user and then commit. And that actually proceeds to removing the data from the disk and inserting the new data. Let's say, for example, we want to create a new purchase for a user and then we want to, as a result of that, update their credit card. But if one fails, we don't want to do the other. We can try to add the purchase, and if that fails, we will roll back and not proceed with the credit card. So this commit allows us to, when we are on a state where we want to save things to a disk, actually save them and not before. So it gives us a bit of freedom, and also it gives us extra speed. Keeping a bunch of things in memory and then writing them all together is faster than writing them one by one, just due to the limitations on how the hard drives work, where the data is getting stored. Now going to writing SQL, I'm going to redirect you over to the next video. SQL is very English-like, so the queries are going to be fairly readable. And we're going to do things like selecting data, inserting data, and things like that. But we're going to do that in the very next video. So I'll see you there.
And he say, Cristiano, we have money, we have everything, we have fame. And he say, I have millions and billions, but the most important thing is the family. Keep your family healthy, good, and take care of your family, because this is the most important thing in the world. Apart of that, of course, you have your life, your private life, you have your girlfriend, but in the beginning, your family, it's always with you, for the good moments and for the bad moments.
Hi and welcome back. In this video, we're going to be looking at starting to move our Milestone project from JSON to a database. If you've skipped the last couple of videos and you went straight from CSV to database, that's fine. We're just going to make a couple of changes here. Now, the first thing to do is in the create book table, we're going to create our table. Now, we'll start by opening up a connection to the database. For that, we're going to need SQLite 3. We're going to import SQLite 3 instead of JSON. That's going to give us a few errors in our file, but that's okay for now. To open a connection, you know how to do that. We looked at that in the slides last couple of videos. So go ahead and pause the video and give it a go. Open up the connection, create your cursor, and then come back for we will implement the query here. I hope you got that. What to do is, of course, connect first of all. SQLite 3.connect. And in here, we're going to give it the file that we want to store all our data in. That's going to be data.db. Notice that data.db is going to appear in our project directory and not beside database.py. So it'll appear at the top level, which is pretty nice. Then we'll create a cursor. Then we can perform the query which is going to create our database. We'll do that in a moment. Then we'll have to, of course, commit our connection to make sure that the database does get created and that the table is all in the file. And at the end, we will close the connection. So by the way, I said create database a couple of times there. I mean create table. We're going to be creating a table. Now, the SQL query is going to be a string that we're going to put inside this execute method here. It's really straightforward. All that we have to do is say create table. So pretty English-like so far. Then we'll give it the table name, whatever we want to create. In this case, it's going to be called books. The table name here is for us to understand what it's storing, and also will be used when we want to retrieve data. So books seems like a good name so that we can then, know that we're storing books in it. Then we'll also need what columns are in our table, what types of data we want to store. And these are going to be fairly simple. We want to store the name of the book, the author of the book, and the read status. Okay, so that goes in brackets after the table name. We also have to specify what type of data is going into each of these columns. Name is going to be a text, author is going to be a text, and read is going to be 1 or 0, so it's going to be an integer. SQLite only supports 5 types of data, so it's really simple. Null, which just means empty or void or no data in here, very similar to Python's none. Integer, which means a whole number. Real, which means a floating point number. Text, which just means any string. And blob, which is a binary data field where you can store things like images or documents, PDFs, and so forth. So those are the 5 data types that SQLite supports. And now we've created here our table books with 3 columns, name, author, and read. Notice how we don't have an ID column here, because this is the only table we've got. We don't need to relate this table to any other table in our system, ergo we don't need an ID. The name is going to be what's going to identify our table. As we progress, we will add some more complexity to this, but whichever column is going to be the main identifying column of your table, you can signal it as a primary key. So that's name, text, primary key. And that just tells SQLite that name cannot contain any duplicates, so that no 2 books can have the same name. And also it improves performance when we are going to be searching for specific names. The complexities of primary keys and what that entails won't be explained in this course, but in other courses. Here I just want to talk about Python. Now, when we run this, we will be creating our data.db file, and inside it we'll create our table. And indeed, we can go ahead and run app. And this, before we print this out, we know inside our app that we are calling create book table. So we can stop the app. And now notice how data.db has been created. We can open it. And this is some weird ass data, which represents whatever it is that SQLite is storing here. Notice how it's not terribly readable, but if you open data.db with your SQLite browser, some more stuff will pop up. Okay, this is how to create a table using SQLite. You say create table, then the table name, and then the columns one by one separated by commas, and including the type of data, and for one column, whether they are the primary key or not. Okay, that's it for this video. I'll see you on the next one, where we're going to be inserting data.
Hey Siri, who's the 19th president of the United States?
Here's what I found on the web for who's the 19th.
The fact that I know that Rutherford B. Hayes is the 19th president of the United States that quickly makes me laugh at every school in America that's making kids memorize the presidents of the United States. It's lazy. Every single piece of education in the world that sits with memorization should be eliminated, because information is a commodity. It sits on your phone.
Hi and welcome back. In this video, we're going to look at inserting a book into a database using our database interface here, database.py, and using SQLite. We've looked at creating a table before. Now let's move on to the add book function here. And the first thing to do, of course, is to set up the connection, including creating the cursor, committing, and closing. I'm just going to copy this, which again you should not do. You should type this code, but I've typed this code many times already, so I think I'll be okay. What we want to execute now is going to insert some data. That's the syntax. Insert into. Insert into then we have to specify the table that we want to insert into, and then the values that we want to insert. Notice that now we put some brackets, and in these brackets, separated by commas, go each of the columns in here. So we could do one of two things. The first one is make this into an F string, and then inside quotation marks, put the name, the author, and 0, because that's the red status that means false to begin with. Notice how we put these inside quotation marks? Because this is what's going to get sent to SQLite, and these are around, quotation marks are around these so that SQLite knows they are strings. If we don't put them in, it will think this is a table name, and it's going to get very confused because we're going to try to insert a table into another table, and it doesn't like that, of course. So make sure to put the strings in there so that it knows that these are strings. We can do this. Let's run our app.py. Oh, sorry, I had it running before. I'm going to run it again. And there you see what happens. We get a traceback. Now, how do we analyze these tracebacks? Well, we already know. This is a SQLite operational error. That means something happened when we were trying to perform an operation. And it gives us a nice description. Table books already exists. We tried to create a table books, but it was already existing. Let's close this and add another bit of syntax. You can create table if not exists. This is not terribly English-like, but this will do the job. It will only create the table books if it doesn't already exist. And of course, another option is to delete data.db entirely, and that will be fine. So I'm going to do that as well. Delete data.db, run the app. Now it works. You can stop it. You can run the app again, and you can see that it still works even though we've already got the database there. Let's add a new book. We can say clean code by Robert, and it seems to work. Of course, if we try to list all the books, it's going to go over to our JSON file, so that's not too good. For now, we can only add books. So as you can see, this works, and we can add new books. We cannot list books or, read books or anything like that. Let's stop the app, and I'll go back over to this execute statement. I said there were two ways of performing this execute, and that is the first one is using an F string, but this is not the recommended approach. And here's why this is not the recommended approach. I'll just give you a quick piece of advice. We're going to put the contents of name into this string, and we're going to put the contents of author into this string here. But what you didn't know is that you can run multiple SQL statements all together when you do an execute. So for example, let's say the author was this. Let's say the contents of the author was this. Now, I understand that you probably don't know what this means, but if we put this code right in where author is, what happens is that now we get two statements. This one that inserts a value into books with a name, an empty author, and 0. A semicolon allows us to run another statement, and this statement deletes the books table entirely. And then we get some invalid syntax at the end, which would probably throw an error. But nonetheless, these two statements would have ran. You would have inserted some books, and then you would have dropped the table. This is really dangerous, because this is called a SQL injection attack, and your users can be nasty enough to try to do it. So if you have a direct replacement, this is called string interpolation, if you have a direct replacement of a string into your query, it potentially opens up this path of attack. So don't do this. Instead, what you want to do is remove everything and put a question mark. Remove everything and put a question mark. You can leave the 0 there if you want. Then put a comma after the string, and inside a tuple, type name and author. Make sure that this is a tuple, and then SQLite 3 is going to put this in there, this one in there safely. So if they are a SQL injection attack, you will be safe. So this is what to do. Let's run the app again. I'm going to add another one, Test-Driven Development by Kent Beck. And you can see that this all works as well. And it is a better way of doing things. It's more secure. SQL injection attack, really popular. Don't open yourself up to it in your applications. And the way to do that is do this. Do not use f-strings or direct string formatting on your queries, because that's not safe. Okay, that's it for this video. We've looked at inserting values into our database. Let's move on to the next one. I'll see you there.
So you are here with your daughter who is 21, right? And you were 21 when you became a billionaire. Is that right?
Almost, yeah.
All right, so around that age, you were like the youngest person to become a billionaire. Is that right?
Yeah, in terms of my own, earning it on my own, yeah.
Right, okay, so, which is the most important thing, yeah. So when you were a kid, did you care about money, or you just cared about technology and it just happened?
Mostly I love software. I do remember at the private school I went to, there were other kids whose families were better off, like they had a Porsche or something, but it wasn't that big of a deal. My thing was that I just loved doing software, I loved hiring people, and I was stunned when it ended up being so valuable.
Hi and welcome back. In this video we're talking about extracting data from our tables using the select statement. In this table we've got 4 columns, ID, name and address, and 4 rows, going from 1 to 4. When we want to use a select statement, we have to specify 3 important things. The first one, that we want to actually select data and not insert it, for example. The second one, we have to say what columns we want to get in our result, whether it's the ID column, the name column, or the address column, or all of them, or any combination of them. And finally, we also have to say what table we want to get our data from. In this case, let's get it from this table here, which I'm going to call people. So this would be a select statement. First, the select keyword, then a star, which means all columns, then the keyword from, and then the table that we want to select from. So this means select all the columns from people, and it would give us a result set that looks exactly like the original table. As you can see, it looks the same. 3 columns, 4 rows, all the data is there. Notice how we've not had to specify what rows we want. We've only specified that we want all the columns. That's what the star means. By default, the select statement will select all of the rows, so all of the data in your table. And we're going to learn how to limit that, how to get only some rows very soon, in a couple of videos' time. Let's have a look at another example where we won't select all of the columns, we'll just select a couple of them. And this would be this. Select name, comma, address from people, and that's of course going to give us 2 columns. Name and the address. Notice how the ID column is not present in our result set because we've not requested it with the select statement. Of course, we could select ID and name if we wanted, for example, and that would give us again 2 columns, ID and name, and it wouldn't give us back the address. Totally fine, you can do this if you want. Notice how the general formula here, the structure or syntax of this statement is first of all select, then the columns you want, whether it's a star or whether it's some comma separated column names, then the keyword from, and finally the table. You can also merge them together, so you can select ID, comma, star if you want, but this is a pretty silly thing to do in my opinion. I'm just telling you this because you can do this, but again, you get double the ID columns, which is not very useful in most scenarios, probably any scenario. But nonetheless, it's something you can do. Again, the star just gets replaced by all of the column names in your table. So of course you can use the star as well as other column names if you want, and this is going to come in handy. The fact that we can do this is going to come in handy later on. Doing this with a single table is not so handy. Okay, that's it for this video. I'll see you on the next one.
People's opinion of you is none of your business, nor should you make it yours. You get in a lot of trouble worrying about what somebody think about you. When really, what difference do it make? Whether they wrong or right, what difference do it make? The majority of people who have a negative viewpoint of you really don't even know you.
Hi and welcome back. In this video, we're going to be adding select statements to our Milestone project. First of all, let's remember to delete this Milestone or books file here because we don't need it any longer. Just to make sure that it gives us an error when we try to use it, we're not misusing it anywhere. Then let's go down to our getAllBooks function. And notice how now it's giving us two errors. It's trying to open the books file that no longer exists, and it shouldn't because we don't want to use it. And also it's using the JSON module, which it shouldn't because again, we're no longer using JSON. We want to retrieve all the books from our database, from our table. You know how to do all of this except for actually getting the books back. So, you know how to set up the connection, get a cursor, execute the query that will select all our books, commit, and close. I'd encourage you to give this a go now. Just implement as much as you know about this function, and then we'll explain exactly what we're missing and how it works. I hope you got that. All we have to do is, of course, first of all, open a connection. Make sure to use the same data file as before so that all of these connections go to the same file. Get a cursor. Then execute our query, which is going to be select star from books. And that's going to give us the name, the author, and the read status. Then we can commit. But, of course, we've not actually written anything to our database. We've just read something from it. So there's nothing to save to the disk. Therefore, we don't need to commit in this case. We can just go straight to connection.close. Now, we've not saved the output of this to any variable. So as soon as we close the connection, of course, this is going to get lost. We're not going to have access to our books. And here is the exciting part or the interesting part about cursors. Remember what I explained about cursors, that they are a pointer. When you make a select statement that starts at the very top of your table and then moves over to the next row when you ask for the next row and then goes over to the following one and so forth until you get to the end of the table. Well, now that we've executed a query with a select, the cursor is at the top of the results returned. And we want to go down one by one all of the rows until we reach the end of the table, so that we get all of our rows back. The way we do that is we say, for example, books, which is now our variable of books, is cursor dot. And notice how there are a few fetch methods in here. You've got fetch all, and that's going to give you all of the rows. Fetch many, and that takes an argument here, which is how many rows you want to fetch. And fetch one, which gives you the top row of your table, of your result set only. So we're going to go for fetch all. And remember that our results are going to be the entire table because we've selected star from books, which gives us all the columns. And we've not limited any number of rows. We don't know how to do that yet. We're going to learn in a moment. So this is going to give us the entire table. Cursor.fetchAll is going to give us all of the rows. If you wanted just one book, you could just fetch one, but that's just going to give you the topmost book in your table. Now this, when you do fetch all, is going to give you essentially a list of tuples. Each tuple is going to have name, author, read status, and then name, author, read status, and so forth. So when you do fetch all, you essentially get this list here. So we can return that and then make our program access the 0th element of a tuple, the first element of a tuple, the second element of a tuple, or we could convert these tuples that we're receiving, I'm just going to bring them back actually, convert these tuples we're receiving into dictionaries so that the rest of our program can still use them as it would normally. And I think this is the best thing to do. Just make sure we are using consistent data structures. So again, what to do is fetch them all, but put this in a list comprehension. And what we're going to do in this list comprehension is put in a dictionary of name. It's going to be row 0. Notice how that's going to be the first element of the row. Author is going to be row 1, and read is going to be row 2. And I know that things are disappearing off the side of the screen, so let's just bring them back. I'm just going to delete this now. And now notice how we have a list comprehension that puts a dictionary, that's the first value here of our list comprehension, into this new list, where row is each of the elements in cursor.fetchAll. Notice that each of the elements is a tuple, so we access row 0 as the name, row 1 as the author, and row 2 as the read status. Hopefully this makes sense. As we do this, we'll end with a dictionary, with a list of dictionaries, where each dictionary represents our book. Then at the end, after we close the connection, we can return books. That's the list here. Now our app.py, which was using book name, book read, and book author, doesn't have to change at all, because it's still using a dictionary in the background. Even though our database does not return dictionaries, the interface that we've designed here has kept things consistent so that our business logic, our app.py, doesn't have to change. And that's a really good thing to do. Now that we've selected all of the books, we can go and look at the next thing, which is filtering for specific books using the where statement. Let's look at that in the next video.
You just don't succeed in any endeavor unless you've got a team that's been supporting you. And that's part of my political philosophy. It's really based on my own experience, which was, if somebody hadn't been out there looking out for me, starting with my mom, my grandmother, my grandfather, then I wouldn't have made it. It wasn't because of my brilliance or something that these things happen. It had to do with people investing in you. And so we've got to make sure we're investing in the next generation, just like somebody invested in us.
Hi and welcome back. In this video, we're looking at update and delete. And I wanted to talk about this briefly before going into filtering, just so you know why filtering is so important. Let's say we've got this table here of our people, and we want to do an update. This is a good old normal update statement. We do update, then the table name that we want to update, and then we say set, and we give the column and the value we want to end up with. So here we're going to essentially update the people table, setting the name column to be equal to Jose. Now, I hope you realize what this is going to do, but if you don't, that's totally okay. We're not told that to update any given row. So we've just said update the whole table and set the name column to Jose. So of course it's going to do just that. Notice how in our results, all the rows, now have a name Jose. It's a good name, but you probably don't want to change all your customers or all your people in your table to have this name. It would get a bit boring. So this is not a good thing. What we've done here is we've said update the people table and set the name to something, but of course we've not told it what we want to update specifically, so it's just gone and done everything. Here's another example. Delete from people. This is a delete statement, allows us to delete a row or multiple rows in this case. And again, we've not told it what to delete, so of course it's all going to go. And we'll end up with an empty table. This is why we need filtering. We need to be able to say delete from people, but only these specific rows. Otherwise, we'll end up with everything deleted. And trust me, you don't want to do this. This happens a lot. It happens to everyone eventually, that you forget to put in a filtering statement in there, and it is a dangerous thing to do. So you don't want to do this. Let's look in the very next video at how to use filtering to make sure that this problem doesn't happen. I'll see you there.
I have to say why people hate you.
You know, you get some of the credit when things go good, and when things are going tough, then you're going to get some of the blame, and that's part of the job. But, you know, I'm a pretty tough guy. Are you a tough guy? You look like you're pretty tough, and so you just got to keep on going even when folks are criticizing you, because as long as you know that you're doing it for other people.
Hi and welcome back. In this video we're talking about filtering. And in the last video we looked at a few examples of where missing out on filtering could result in something disastrous, like deleting your entire tables or modifying all your rows to have some new value. Let's make an update now to row number 1 only. And this is how it would go. We'd say update the people table, setting the name now to be equal to Joseph, but we're adding this where clause at the end, a where clause which says ID equal 1. This is only going to change the row that has ID of 1, setting the name now to Joseph. I think Jose is a bit nicer, but you never know. Notice that in SQL, the equal operator is used for comparison as well as assignment. In this case, it's used for assignment. We're setting the new name to be Joseph. But it's also used for comparison here. We're only changing those where the ID is equal to 1. We're not going to modify the ID here. We're just checking that they match. The ID column must be 1. And in Python, we'd use a double equal sign for this. But in SQL, you use a single equal sign because it knows that you cannot change things in a where clause. So you don't need a double equal sign here. Okay, let's go over to another example. Now we're going to select using a where clause. Once again, select star from people where the name is Jen. And that's going to give us only row number 3. Let's delete. Once again, same thing, delete from people where ID is 1. It's going to give us all the other rows other than the first one. Notice that this does change the database. So it's not like you get a result back of this table, but it changes the database and then you could extract this entire result set using a select. So as you can see, the where statement goes in a pretty reasonable place for the English language. Normally at the end, but sometimes it doesn't go quite at the end if there are other clauses like we're going to look at in a moment. Here's a few more examples. Select star from purchases where amount is greater than 150. Pretty English-like, you know, you're selecting where something is true. Select star from users where the registered date is less than this magic number here. And this number, by the way, if you've never come across the integers for dates, so that's a very long integer that represents a date. That's a Unix timestamp. It's a number of seconds that have passed since the 1st of January 1970 at midnight. And it's sort of the way of storing dates in databases, so that you don't have to deal with, you know, formatting. Does the month go first or does the day go first? Just use an integer and everything's solved. We've got select star from people where name is not equal to Rolf. You can do this. And of course you can do select star from purchases where amount is greater than 150 or the type is online. You can also use and, like here. Select star from users where username is Jose and access is admin. Notice, by the way, that I do something that I'm not terribly proud of, which is I don't put any spaces around the equal sign, but I put spaces around the other symbols. When I was making this presentation, I really tried to either put spaces around the equal sign or remove the spaces around the other symbols, but I just couldn't bring myself to it. For me, this looks natural. Maybe it's just because the way I've been doing it for a long time. I couldn't bring myself to add spaces around the equal sign. That just felt a bit wrong. And I couldn't bring myself to remove the spaces around the other symbols. That just felt a bit weird as well. You can put spaces around it. You can remove the spaces. Up to you. This is the way I like doing it. I don't know why. Anyway, so select or update or delete where some clause, some boolean, and you can use or and to add multiple types of boolean. And of course, you can only use the column names that are available on your table to make these comparisons. So you can select where the amount or the type, given that these two are columns on your table, but the star here will get all your columns. You can only get some columns if you prefer. So you could say select ID from purchases where amount is greater than 150 or type is online. That would be fine as well. What I'm trying to say is that these comparisons here don't have to be selected necessarily, but you can if you want. Okay, that's it for this video. I hope you've learned something about how to use filtering. I know we're not going too in-depth in here, but I just wanted to show you enough so that we can proceed with our Milestone project. So with that said, I'll see you on the next video.
You are these iconic characters, but we don't really know much about you. Like, what are your hobbies and likes? And
yeah, I tend to keep myself to myself a lot. Now, I'm not on social media in any shape or form. I prefer to keep all my activities of a personal level, personal and private, just because I find it much more relaxing. I find the whole concept of social media just not
keeping up with it,
sort of
right?
unrelaxing. It feels like an unrelaxing thing, so I don't do it.
Hi and welcome back. In this video, we're going to finish our Milestone project by including the update and delete statements. We've added the create book table, which creates our table if it doesn't exist already. We've inserted a new book into our table, and we've also looked at selecting all of the books from our table and returning them as dictionaries. Now, we've got two more functions, mark book as read and delete book. With our files, what these did was read the entire file, find the appropriate book, update it, and then save all the books back. With SQL, we can actually find the correct book by name on the database and update it in place, so we no longer need to get all the books, change one, and then save them all back. For that reason, I'm going to delete this save all books function, and that's a good reason why it had the underscore in the beginning. It was something that we wanted to use internally to make our interface work, but it wasn't something we wanted the app use. So that's why I had the underscore before, to mark it as sort of private, so that other parts of our program wouldn't want to use it too. To mark a book as read, you know how to do this now, because we have to initialize a connection, get a cursor, execute our update statement with a where clause that would where by the name, and then commit and close the connection. We don't even need to return anything or get any data out of the database in order to do this. I think you can implement this function on your own, so give it a go. I'm sure you managed to do that. We've just looked at the update, and all we have to do is again copy this boilerplate SQLite3.connect to data.db. Make sure to use the correct data file, get a cursor, then execute our SQL, and this is going to be update the books table, set the read to 1, where the name is equal to a question mark. Remember, you must not use f strings here, because that opens you up for potential SQL injection attacks. So what we're going to put here is a tuple of name. And notice that in order to make a tuple, we have to include the brackets, as well as the comma, in order to say this is a tuple. It's not a mathematical thing that we want to evaluate first. And certainly, if you don't put the brackets in and you just do this, it thinks that this is an entirely new argument to the execute method, which we don't want to do. We want to make sure it's a tuple, so we do it like this. Now that we've ran this, we want to make sure that these changes get saved to disk. So connection.commit, and finally connection.close. And that's it. Now we've updated our book, set the read flag to 1, where the name was equal to name. Going over to delete book, I think you can also implement this. For what we have to do is pretty much the same. Once again, pause the video and give this a go. Now, I'm sure you really managed to get this. What I'm going to do is copy this boilerplate, not something you should be doing very often. But instead of updating, we're going to say delete from books, where the name is this question mark. And once again, the name gets passed in as an argument there. Then we commit, once again, and we close. We don't have to fetch any rows or anything, because there's nothing for us to return from this delete statement. And that's it. We've got all the data in and out of our database that we needed. We can go back to app.py And all we have to do is potentially update this book red flag here. We could say, yes, if the book's red status is true, otherwise no. But what you didn't know is that if 0 actually evaluates to false, and if 1 evaluates to true. So if book red is 1, contains the integer 1, we're going to get yes. If it contains the integer 0, we're going to get no. So we don't actually have to change this at all. Python automatically treats 1 and 0 as true and false as well, which is pretty handy. So we don't actually have to make any changes at all to our app.py, which tells us that we've done an excellent job isolating our data storage device, our database, from our business logic. And I keep going on and on about this interface because it's really important part of programming to be able to decouple your different components and make sure that they can operate without knowing how the other one is implemented. That's really important. Let's go ahead and run our app. And then we can look at adding a new book. Oh, and we get an error. We get an error that says, integrity error, unique constraint failed on books.name. That means that a book with this name already existed in our database. Interesting error. Of course, we know that this should be an error. We don't want the same book twice. So what happened is that our data.db was existing from the last time we ran this and I entered the same book. So if you want to get rid of this error just temporarily, delete data.db and run your app again. Then you can enter clean code. Then you can list all your books now, and that gives you clean code by Robert C. Martin. You can, of course, mark a book as red. Then you can list the books again, and it gives you clean code by Robert C. Martin. You can delete a book. Not that you'd want to delete this book. And then you get nothing when you list the books back again. So we've made our program work with a database, a SQLite database, which is very, very similar to a Postgres or a MySQL database. The way we interact with it using SQL is pretty much the same. Postgres and MySQL are more powerful. They do more things for you. And they also have a bit more functionality, more different types of data you can store, and so forth. But really, what we've covered is the same amongst all major databases, which is really cool. Of course, we haven't gotten rid of the insert error when we insert something that already exists, but you could do that. You could put a try except here on a integrity error and just print out something that says we couldn't put out your book, or you can return false potentially, and then in your app.py say if this succeeded, print nothing, and if it didn't succeed, print you've already got that book in your database. Feel free to extend this as far as you want, and of course ask questions in the course Q&A if you encounter any issues. We'll be happy to help you. I'm not going to bore you any longer with continuing with this project. We can move on to better things. So with that said, I'll see you on the next video. We're going to talk briefly about one more thing in SQL that we didn't get to use in this project, but still pretty important, and then we can go over to the following section. I'll see you soon.
I bought a house.
Sir, how is that possible? You're 12.
It's my money, but like under my dad's name.
Did you just say you're laundering money for your father?
Laundering money? I don't know if that's good or bad.
He puts his father's money in the laundry? Are you still in school?
Yeah, I go to public school.
That's crazy. Let me ask you a question.
Yeah.
And I want you to be honest with me. How much money have you made from YouTube at 15 years old?
Take a guess. I'll say higher or lower.
Okay, great. $500,000.
Higher.
You've made more than this 15-year-old kid has made more than
$882,000.
A little higher.
Wow.
Hi and welcome back. In this video we're talking about ordering and limiting. These are two things you can do with SQL that can be pretty handy in a number of scenarios. Let's have this purchases table here that has 3 columns and 4 rows. Notice how there's an ID, an amount, the money that was paid for this purchase, and also a date, which is a Unix timestamp. We could do something like this. Select star from purchases, and now instead of where, or indeed as well as where, we can use order by amount. This is going to order in ascending fashion, giving us something like this. $9.99 at the top, followed by $14.99, $15.99, and $150. Of course, we could order by amount descending instead, by just putting DESC at the end for descending. And that gives us $150 at the top, going down to $9.99. And if for some reason you wanted to make it explicit that you want it ascending, you can use ASC instead of DESC. Ascending is the default, so you don't have to include it in SQLite, but it's possible that other database systems may be different. You can order by amount descending, that's the largest at the top, and limit 1, and that's going to give you only the topmost row of your database. That's the most expensive purchase that anybody has made, and potentially you could do then things like notify the user that has made this purchase and tell them they've won a voucher or something for spending the most money in your store. I don't know, but you see the deal there. You can get the topmost of something, and indeed instead of limit 1, you can do limit 2 or limit 3 if you want to get the top 3 of something. So these two, order by and limit, are pretty handy to use, and you can use them together. If you wanted to put a where clause, it would go before the ordered by clause. So you can also put that in there. Again, this course is not meant to be a in-depth SQL tutorial. I just wanted to guide you enough so that you can sort of interact with tables and store and retrieve some data. If you want to learn much more about SQL, then I'd encourage you to go and investigate, read stuff online, implement your own projects that use them, and learn through that. And of course, you can also take some other courses if you're so inclined. But that's it for this video. I just wanted to guide you through ordering and limiting, and I'll see you on the next one.
You know my teacher how to hit me? How? With the word flat. Yeah, no yowling, no up, no tear. And the first one, okay, I just do this. Then he said, remember, okay? Don't do it next time. Okay?
And still no tear.
Then the second one, he just, no, again. He want to hit me 10 times, but each time is again. But after 3 times, my tear come out. No, wipe. Okay, start all over again. 1. At the end, I look at him. I just 2, 3, 4. At 10, then I look at him.
Hi and welcome back. In this video, we're going to talk about context managers, and we're going to be developing our own. This is not something that a lot of Python courses get into. So you should feel pretty good that you're getting this deep into the inner workings of Python and how to do some pretty advanced stuff. In the last section, we looked at files, and particularly at a new bit of syntax that said something like this. I'm just going to put it here, and I'm going to delete it in a moment. With something, 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 as something, 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 colon, and then do stuff. And this here was the context manager. And by context, we mean that the current status of the application at the point in which this block runs is modified by this statement and is controlled by that statement. You could even say it's managed by it. And that means that it modifies the status or the context when you go in, and it also modifies it when you go out. That allows you to do some setup when you start and some tear down when you end. We can create our own context managers, and it's reasonably straightforward, so that we can use that syntax for our database connections. We can see, and I've been pretty explicit throughout this section in, for example, copying and pasting code, we can see that we've got a setup and we've got a teardown. And this happens for every function in this file, pretty much, except for this one that doesn't have a commit. So as you can see, there is here a good idea that is using a context manager so that we don't have to get this done every time. Let's create a context manager for our database connections then, so that we don't have to open and close the connection every time. In order to create a context manager, all we have to do is go into our utils package, for example, and create a new Python file, which I'm going to call database connection.py. This database connection is going to import SQLite 3 because it's going to actually connect to the database and it needs SQLite 3 to connect. And it's going to be a class, database connection class. A database connection, in order to be able to be used as a context manager, it of course needs two dunder methods. Remember, dunder methods are the way that everything happens in Python. And if you want to use a with statement, you need two dunder methods. You need enter and you need exit. Notice how the exit method has a few arguments here. We're going to talk about what these are in the next video, so don't worry too much about them right now. Naturally, the enter dunder method is called when you go into the context manager, right before you start running it, and the exit method is executed right when you leave the context manager. When we now have these two methods, we can go over to database.py, we can remove this SQLite 3 import, and instead we can say from database connection, notice how I'm using a relative import here, .database connection, import database connection class. Now, instead of doing this, we can say, or rather, instead of doing this here, we can say with database connection as connection. And then we can just keep this stuff here. Of course, this has to be indented so that they are inside this context manager block. Okay, this is the syntax. With database connection, create a new object of type database connection. As this connection variable, this is the variable we create now so that it can be used inside the context manager. And then we can create a cursor with it. And then we can execute whatever we want. Of course, we could make this database connection return a cursor object, but I think that would be fairly confusing. A database connection probably should return a connection and not a cursor. So, of course, our enter and exit methods don't do anything yet. So this connection variable here is going to contain none. That's what this enter method returns. Pass just means do nothing. All functions, all methods in Python return none by default. So this connection variable will be none. We don't want to do that. Of course, here we are also creating a new object. Therefore, if we want, not necessary, but if we want, we can also have an init method here. This init method is going to be called first when we initialize this object, and then the enter method is going to be called as we go into the context manager, and the exit method is going to be called as we leave the context manager. Of course, we have to initialize the connection. We have to do this SQLite3.connect. So let's do it. I think we should do this SQLite3.connect in here in the enter method. So we can return SQLite3.connect data.db. Now, when we go back to database.py, this connection variable is now a SQLite3 connect result. It is the result of whatever the enter method returned. So that's correct. Now, this will all work, but when we go to the end, we've not yet added any code to commit and close the connection. So we have to do that in here in the exit method. Now, we don't have access to this connection inside this class. There's no way to access the connection that we've got, and it's not passed to us as a parameter. So what to do is use this init method to say self.connection is none. Then we're going to say self.connection is this connection here, return self.connection. Now we're doing the same thing, but we've defined a new property of our database connection class that is going to store the SQLite3.connect result. The enter method is going to return that, which means it's usable from our database.py, and now we have access to it here in our exit method as well as self.connection. So we can do self.connection.commit and self.connection.close. There are some instances where we won't need to commit, but it's okay to leave that there even when we don't need to. SQLite will just not do anything if we call commit, but there's nothing to commit, no changes made to the database, so this is fine. Okay, I would improve this by also saying self.host equal host and pass this in here as a parameter to the init method, and instead of data.db, use self.host. That way, when we go back to our database.py, we can say data.db in here, and that makes things a bit more explicit. We can see that we're now connecting to a database called data.db. We're getting the connection here. Presumably, everything is being handled, including closing the connection and everything like that. This looks pretty similar to with open books.txt in read mode as file. As you can see, the open here is a class as well. It's creating a new object of type open, and it's getting 2 parameters to the init method, and then the enter function inside this class is returning a file, which we're using as this variable here. Very much the same. Of course, this has another argument there, but that's fine. What we've done is we've created a new object and we've given it what we want to do with that object, connect to database.db, and that is going to handle everything for us. This with statement is a very Pythonic way of writing code. It's not something that other programming languages have, and I really encourage you to use it. Now that we've got it, of course, we can copy it and use it on all of our functions. In the add book, we do exactly the same thing. Notice how this context manager is going to commit at the end as well, so nothing to do here. Also here, we can, of course, do all of this. We don't have to close the connection, and we can return books either inside or outside the context manager. It's up to you, it doesn't matter. But I'm going to leave it outside just for kicks. And then we can do it here as well, of course. And we can, of course, also do it here. Now, this code is made much simpler. None of this code has to deal with connecting to a database, or committing, or closing the connection. All of that is done for us with this context manager. And that means that if we were to forget to commit or close or something, now we can no longer forget, because as soon as we do this, everything is handled for us. You could try to make another context manager which generates the cursor, and then use a single context manager for both. You can try that if you want, play around with it, and see what you come up with if that's something that interests you. Context managers are really exciting, and it's quite cool to work with them and really finally understand what's going on behind the scenes. And with almost everything in Python, what's going on is that some dunder method is getting called. Okay? And when you do with, the init method gets called first for the object you're initializing, then the enter method, and finally the exit method at the end. In the next video, we're going to look at these 3 things here, so don't go anywhere, and I'll see you on the next video.
You only have to be right one time. You don't have to figure it all out in advance. You can be wrong. You can pick the wrong career. You can pick the wrong job. You can pick the wrong spouse. You can pick the wrong whatever. But you get it right one time, you're set. But if you don't try, and if you don't go out there and try all those different things, you'll never get that one time.
Hi and welcome back. In this video, we're looking at how to deal with errors in context managers. The exit method, the dunder exit method of a context manager has 3 arguments: exe type, val, and tb. These stand for exception type, exception value, and exception traceback. We're going to look at exactly what they are in just a moment. And these things exist because during the execution of a context manager, it's possible that an error will occur. For example, if we go to our database.py into the add book function, we could encounter an error when we try to insert a book with a name that already exists. In that case, an error will be raised by SQLite, and before it crashes our program, it will go to the exit method. Okay? So even if an error is raised, we'll still call the exit method first, and it will have some values here. And then once the exit method has finished running, the error will continue to be raised and will crash our program, unless it's handled in a try except. If no error occurs, all of these have none value, so all of these are none by default. So here's some sort of stuff that we can do in exit. Of course, we can close the connection, even though an error happened. Otherwise, we would have to use a try except here. So earlier on, when we got an error in inserting a book, we didn't actually close the connection because the program crashed before that. Now, even if we get an error on the execute, we still go here and we commit and close. We can close the file even though an error happened, same thing as here. We can print something to the console when something finishes executing, particularly if an error happened. We can say, hey, we ran this context manager, but an error happened during its execution. We can destroy anything we depended on in the code in the context manager. So for example, we could destroy this connection, we could destroy a file handler, we could do anything we want. Remember that context managers are just that. They are functions used to manage the context, and Python gives us some syntactic sugar, the with statement, that allows us to do these things, but they're just functions running at the start and at the end. It just so happens that the exit function gets called even when there is an exception, an error, which is pretty much the same as a try except block. You can do this stuff manually without using context managers, but it's probably going to end up being less readable. And so this is probably the better choice, and Python really likes these context managers. These add readability and reduce repetition in your code, which is good for one of programming's core tenets, which is don't repeat yourself. Okay. Let's go and set a breakpoint inside line 14, the dunder exit method here of our context manager, and then we are going to run our app. We're going to add a book, which is going to be clean code, and then we're going to add the same book again. Notice how now we get an integrity error here. It says, unique constraint failed, books.name. And that's in here in the SQLite 3 integrity error happened when we tried to execute this thing. Now, let's go ahead and debug our app this time. And once again, go to the console. Oh, I think we may have... Oh yeah, sorry. This has ran. We don't need to do that. Let's go to A, type clean code. And now notice how our code stops in here. We can go over to the debugger and see that we have a couple of values for the execution value and execution traceback. We've got the traceback is this traceback object, and the value is this unique constraint failed on book's name. So when we have an exception happen, the exit function gets called, but it has some values in it. I wondered if exe type has any value. Yes, it does. This is the integrity error that we got earlier. This is a type of the error that was called. So as you can see, these are not none anymore. They have some values. So what we can do is we can stop our program and we can say if exe type or exe val or extb self.connection dot close without committing anything. Otherwise, commit and then close. The reason for this is that if an error happened, it's possible, although unlikely, that our database has been left in an inconsistent state, a state that is not so good. For example, if you try to enter some data first and then you want to enter something else that depends on the previous data, but you get an error when that happens. So what to do is if there is an exception happen, close the connection, otherwise commit and then close. Notice how if exe type or exe val or extb just means is not none. These are all the same thing. Exe type is not none, or exe val is not none, or extb is not none, can be shortened to this. So feel free to use this type of syntax instead. Remember, the OR statement gives you the second value if the first one was falsy. None is a falsy value, so this gives you exe val. Exe val is none, which is also falsy, so that gives you extb. Extb is also none, which is also falsy, so then you go into here, because this whole thing evaluates as extb, which is false. Okay, then if not, you run the else, which commits and closes the connection. So that's it for this video. I just wanted to show you what the exit method parameters are and what type of things they hold. And the type is the exception type, that's the class of the exception. The value is any arguments that were passed to the exception when it was raised. Normally that's a description message. And the TB is the traceback of the exception. That's where the exception happened in all the lines and all the files where it was seen. So that's it for this video. Hope you've learned something, and I'll see you on the next one.
You feel like other people have given up on you, don't ever give up on yourself. Every single one of you has something that you're good at. Every single one of you has something to offer. And you have a responsibility to yourself to discover what that is. My father left my family when I was 2 years old. And I was raised by a single mom who had to work and who struggled at times to pay the bills and wasn't always able to give us the things that other kids had. There were times when I missed having a father in my life. There were times when I was lonely and I felt like I didn't fit in. So I wasn't always as focused as I should have been on school. And I did some things that I'm not proud of. And I got in more trouble than I should have. And my life could have easily taken a turn for the worse. But I was lucky. I got a lot of second chances, and I had the opportunity to go to college and law school and follow my dreams. My wife, our First Lady, Michelle Obama, she has a similar story. Neither of her parents had gone to college, and they didn't have a lot of money. But they worked hard, and she worked hard so that she could go to the best schools in this country. But some of you might not have those advantages. Maybe you don't have adults in your life who give you the support that you need. Maybe someone in your family has lost their job and there's not enough money to go around. Maybe you live in a neighborhood where you don't feel safe or have friends who are pressuring you to do things you know aren't right. There is no excuse for not trying. Where you are right now doesn't have to determine where you'll end up. No one's written your destiny for you. But whatever you resolve to do, I want you to commit to it. I want you to really work at it. I know that sometimes you get that sense from TV that you can be rich and successful without any hard work. That your ticket to success is through rapping or basketball or being a reality TV star. Chances are you're not going to be any of those things. The truth is, being successful is hard. And you won't necessarily succeed at everything the first time you try. That's okay. Some of the most successful people in the world are the ones who've had the most failures. J.K. Rowling, who wrote Harry Potter. Her first Harry Potter book was rejected 12 times before it was finally published. Michael Jordan was cut from his high school basketball team. He lost hundreds of games and missed thousands of shots during his career. But he once said, "I have failed over and over and over again in my life, and that's why I succeed." These people succeeded because they understood that you can't let your failures define you. You have to let your failures teach you. You have to let them show you what to do differently the next time. So if you get into trouble, that doesn't mean you're a troublemaker. It means you need to try harder to act right. If you get a bad grade, that doesn't mean you're stupid. It just means you need to spend more time studying. No one's born being good at all things. You become good at things through hard work.